So today we are going to start the second part of this chapter, and in this part we will be discussing all these topics. First we will discuss the Galileo's observation and the conclusion made by him, then the first law of motion, which is also known as the law of inertia, then the relation between inertia and mass, and finally we will discuss the second law of motion, right? Okay. So first of all, let us understand the Galileo's observation. So actually what he did, he observed the motion of objects on an inclined plane, right? So uh, to observe the motion of objects on inclined plane, he used a marble. You all know what is marble. The marble which is used for playing the games, right? The spherical one, small marbles. He rolled down the marbles on the inclined plane. He noticed that when he rolled down the marble on the inclined plane, the velocity of the marble increases. It was increasing. Okay. So this was the first plane. This is the second inclined plane. This is the second inclined plane. So when he allowed the marble to roll down from the first plane, the velocity of the marble keeps on increasing until it reached the bottom of that plane, of the first plane, right? So the speed was maximum at this point. Means we can say that suppose when he left, the speed was 0, then somewhere in between the speed became 5, and finally at bottom the speed became 10. Let us take these values. Okay, right? Then what he did, he also placed, he has placed one more plane in front of it. So of course the ball which has reached down, it will start moving upward on the second plane. So on the second plane the ball started moving, and while moving towards the top of the second plane, the speed started decreasing. For example, suppose at this point it was 10, then it became 5 over here, then on reaching over here, it again became 0. The speed again became 0. Okay. So he noticed that the height from which the ball was dropped from the first plane, means this height, let the height be h. Okay, we can see a line over here. This line, you all can see the ball reached at the same height. The ball reached the same height even on the second plane, and only after reaching the same height, the speed of the ball became 0. Okay, so it means what? What he said, that when a marble is rolled down from left side, that is from this side, it will go up on the opposite side. Okay, and till where it will go? Up to the same height. Okay, it will go on the second plane, that is on the right plane, up till the same height from which it was dropped. So this all what it concluded. Okay, so two things we have to note over here is that on the second plane, ball reached same height. Right? This is the first point that we can note from this experiment. Second, the speed becomes 0. On reaching that maximum height. Right? these 2 points we can conclude from this experiment, right? Now it's given that if the inclination of the plane is equal, okay, saying the inclination is equal means if suppose both the planes are having same angles over here with the ground, if both the planes are having same angle over here with the ground, means let us say that both are having both are at 30 degree, both are at 30 degree. Suppose if both are at 30 degree, then in this case, if a ball is left from this side, it will stop after reaching the same height on the second plane, right? It will fall down and it will again rise on the second plane, and it will stop only after reaching the same height. So the distance covered by the marble, that is, a marble would travel equal distance while climbing up as traveled while climbing down. It means we can say that if the marble is covering, suppose 15 centimeter, suppose the marble has covered 15 centimeter while moving down, then uh, in moving up on the second plane, it will even on this side it is going to cover 15 centimeter. Okay, means if the inclination is same, the distance covered on both sides would be equal, right? So understood this one? Now next what he did, he said that if we decrease the angle of inclination of the right plane means the plane which is on right side, then the marble would travel further until it reaches the original height. It is very simple. Means say that uh, that this plane, okay, the means this angle is less. Means say this one is 45. Let this one be 45. The angle is 45, and on this side the angle is let it be 30. Let it be 30. So if the angle is 30, of course the path or the length would be more, okay, to reach the same height. So the on this side the ball will cover less distance, but on this side the ball has to reach the same height, so it will cover more distance. It is going to cover more distance while on this whole path, right, till this path. So it's very, I think it is simple. It is a very simple thing that it is going to cover more distance because it has to reach the same height. Okay. Similarly, means if it is like this, okay, and the second plane is somewhat like this. If the ball is dropped from here, then of course it is going to reach the same height. It is going to reach the same height. It will fall down. It will rise up till here. So clearly we can see clearly that on this side the length covered is less, that is the distance covered is less, while on this side the distance covered is more. So if we will keep on decreasing the angle of the second plane, that is this angle, it will keep on decreasing the angle, the distance covered by the ball will keep on increasing, right? Okay. Now I'm asking few questions to you. Okay. The very simple thing, if suppose when a ball rolls down an inclined plane, the speed of the ball increases or decreases? Type in chat box. When the ball rolls down, the speed of the ball increases or decreases? Please type in chat box, all of you. Each and everyone is have to answer. Huh? Okay.
Increases.
The speed of the ball increases, right? So it is clear to everyone. You also might have experienced this one. Okay. Now suppose if the inclined plane is like this, and the ball has to move upward. Now the speed will increase or decrease?
Decrease.
Type in chat box. Yeah, it will decrease, right? It will decrease. So when a ball moves upward, the speed decreases. When a ball moves downwards, the speed increases. But if suppose the surface is straight, that is flat. Now if a ball is allowed to move, the speed will remain same, increase or decrease. Just types, if it is same, type same in chat box, or type increase or decrease. Yeah. So in this case, the speed remains same, right? The speed remains same. Okay, so these three things is clear to everyone, right? Now, there's a little bit change in the Galileo's experiment. What he did, the right side plane is made flat. Okay, means the plane which was here, it has been made flat. It has been made flat means the angle has been reduced to 0. The angle has been reduced to 0. We can say that the angle, earlier there was some angle, then it has been reduced to 0. Means suppose we will keep decreasing the angle, the plane will look like this, then this, okay, then this, and finally when it is completely flat, the angle is 0. And we have seen that just now we have discussed that if this angle is reduced, means if this angle is reduced, uh, when angle is reduced, then distance covered, the distance covered increases, right? When angle is reduced, the distance increases, right? The distance covered by the marble increases. So now the angle has been completely reduced. Now it is 0. Now it is 0. So the what would be the distance, or how much is the distance increased? This we have to check. So he mentioned that if the right side plane is made flat, the marble would travel forever to achieve the same height. Okay, we know one thing, that when a marble is dropped from one side, the speed becomes 0 only when it reaches at the same height. Only when it reaches from the same height. Okay. So when the marble is dropped from here, initially the speed was 0. Somewhere here the speed will become 5. Suppose the speed will become 5. At this point, say the speed will become 10. Now, according to this condition, like you have said, that if the ball is going to move on a straight plane, the speed will remain same. So once at this point the speed gained by the marble is 10, and further the path is straight, so the marble would keep moving with the same speed or not? Just tell me what would be the speed for this position where the question mark is given. Type in chat box. What would be the speed for this position? At this position, the speed is 10, and for a straight path, the speed remains same. So what would be the speed for this position? Only, yeah, Deepika, Sushant has answered. Rashi, okay. Yeah. So, yes, you got it. Even at this point, the speed will remain 10. Okay, from this one we can say, that for when a body moves at the same on a straight path, the speed remains same. Okay, but there is a condition. The condition is there should be no friction. In absence of friction, the speed will remain 10. The speed will remain 10 until the ball is going to move. And till what time the ball is going to move? The ball will move forever. The ball will move forever, because on moving on the straight path, the ball is never going to achieve this height. On moving at the same path, the ball is never going to achieve the height from which it was dropped. Right? The ball is never going to achieve the height from which it was dropped. And as from the previous cases, we had concluded that the speed of the ball becomes 0 only when it reaches the same height, and here it is not reaching the same height. So the ball will keep moving forever unless there is no external force acting on it, that like friction, right? So this is what he concluded. So let us see what is the Galileo's inference, or what is the conclusion. He said that we need an unbalanced force to change the state of motion of the marble. Means uh, here we can say that, like this ball, we need an unbalanced force to move a ball, to change the state of motion of a ball. Means either to stop a moving body or to move a stationary body. Okay, but but no force. This is very important. But no force is required when the marble is moving uniformly. When the marble is moving uniformly. Okay, means he is talking for this path. Once the marble has gained a speed, suppose at this point it was having a speed of 10 meter per second or 10 centimeter per second, and it is moving on a straight path, and in case if there is no friction, or no external force acting on it, then the marble doesn't need any more force to be applied on it to keep the marble in motion, okay. Means no force is required when the marble is moving uniformly. In other words, what can be said in other words, that this is the most important sentence: object moves at a constant speed if no force acts upon them. Object move at a constant speed if no force acts upon them. Okay, this is what was concluded from Galileo's experiments, right? All this work done by the Galileo was studied by Newton, and the Newton formulated three laws based on the experiments, and he gave the first law, which was completely based on the Galileo's experiment. And actually it was the Galileo's statement, but he reframed it in a better way. Okay. So let us understand that. So the first law of motion given by the Newton, which is also known as the law of inertia. It is also known as the law of inertia, right? So the statement is, a body continues to be in state of rest. Means if a body is at rest, the body will try to be at rest, or the uniform motion. Means if a body is in uniform motion, the body will remain in the uniform motion. Means if a body is moving, it will keep moving. It will keep moving in a straight line, unless acted upon by external unbalanced force. Okay, means what? Let us see an example. Okay, and this is more very important, that first law is also called as law of inertia. So if law of inertia is asked, you have to write the same law. And this is a new word for you, inertia. No, I think this was explained in it. Then also I will explain it again. Okay, so what is Newton's first law? See here, a ball which is placed on the ground is at rest, so it will remain at rest. Even if a ball is left for 2 hours, it is going to be there for 2 hours unless any external force acts on it, right? Now this is the external force acting on the ball. Okay, someone is kicking the ball, so that is an external force, which is also an unbalanced force, right? That is an unbalanced force. So the ball is set in motion. Okay, so on when an unbalanced force acts on the ball, the state of the motion will change from rest. Earlier it was at rest, and now it is in motion. Now it will continue moving unless the other external force will try to change its position. So here, when the ball hits the net, finally the ball is going to stop. The ball stops when it hits the net. Okay, so here net is applying unbalanced force on the ball, because of which the state of motion, the earlier the ball was in motion, that state has been changed, and now again the ball would be at rest. Okay, so from here what we from this example, what we can understand, that the if an object is at rest, it will be at rest unless some other force acts on it. Similarly, if the object is in motion, if an object is in motion, it will be in motion unless some other force acts on it. But actually, whenever a body is moving, the body gradually slows down and it stops because of the force of friction. And that force of friction is again an example. It's a kind of unbalanced force, right? So I hope this
Sir,
first law is clear to everyone. So this was the first law. Moving on to the next topic, that is inertia. Okay, what do we mean by inertia? So inertia is actually a property or tendency of every object. It is tendency of every object, even you as an object, to resist any change in its state of rest or of uniform motion, or of uniform motion. Okay, or of uniform motion. It means what? That every body resist any kind of change. Means if a body at rest, if a body is at rest, that body will not will try to change the position of the rest. Means it will not it will, when if a force is applied on it, it will try to oppose that force. Means it will try to be at in the same position. And if a body is in motion, it tries to be in motion. Okay, this is a definition. It will become more clear once we will discuss once I will give you the examples. But first let us discuss this one, that on what factor does the inertia depends. So the inertia is it generally depends on the mass of the object. It generally depends on the mass of the object. Hence, mass is also called the measure of inertia of an object. It is also called the measure of the inertia of an object. It means if you want to check that whether the inertia of a body is less or more, so you need to check the mass. Means if a body is heavier, if the object is heavier, of course the mass is more, right? So the inertia will also be more for the heavier object. Similarly, for light objects, the inertia is less, and if inertia is more, the body will resist more. If inertia is less, the body will resist less, and hence the body with less inertia, that is the light objects, can be or the state of rest or motion of light objects can be easily changed. It can be easily changed. Okay. For example, if you will look at this figure, there are two buckets filled with one is filled with sand and the other is empty. This one is empty and this one is filled with sand. If you are asked to apply a force to move the bucket, so which one would be easier for you, the first one or the second one?
first.
First one would be easier because it is empty, so mass is less, and so inertia is less for the first one. But for the second one, it is filled with sand, so the mass is more, so it is difficult to move this one. Okay, so inertia completely depends on mass, and it is a property which tries to resist any change. If a body is at rest, it will resist motion. If a body is in motion, it will resist rest. Okay, exactly opposite. Now, the next one, that is few examples of inertia, or what are the applications of Newton's first law of motion. So let's read this one. It is given that when a straight moving bus suddenly stops, what happens? The passenger sitting aside falls in the forward direction. Yes or no? You might have seen this.
Yes.
Okay. Even
Yes.
here we can see a figure that okay. Uh, Let me explain this one. And why it is happening? This is because the body of the passenger is initially moving in a straight line, which tends to move same even after the brakes are applied. And this is why passenger fall in the forward direction.